A young couple in Ohio bought their dream home for $210,000, and 18 months later, a fire investigator stood in their scorched hallway holding a piece of blackened wire that told the entire story before anyone said a word. The damage came to almost $90,000, and the cause wasn't a storm, a candle, or an old appliance. It was a single decision made by a previous homeowner who thought he was saving $400 by doing the wiring himself. If you've ever looked at your breaker panel and wondered what's really happening behind those walls, you're going to want to stick around, because every week we dig into the hidden mistakes inside American homes that quietly turn into disasters. And understanding them might be the difference between a safe house and a very expensive phone call to your insurance company. Electricity is invisible, and that's exactly what makes it so dangerous. You can't see it building up inside a wall the way you can see a crack spreading across a foundation. You can't smell it the way you can smell a gas leak. It just sits there, silent, waiting, and most homeowners have no idea it's a problem until something goes wrong. The story usually starts the same way. A homeowner wants to save money. Maybe they're finishing a basement, adding a ceiling fan, or wiring up a new outlet for a home office. An electrician quote comes in at $800, and a trip to the hardware store costs $80. The math seems obvious. What isn't obvious is what happens inside the walls once that work is done. Take something as simple as connecting two wires together. It looks easy. Twist them, wrap them in electrical tape, and move on. But here's where everything changes. Underneath that tape, if the connection isn't tight and properly secured, tiny gaps form between the metal strands. Every time electricity flows through that loose connection, it creates heat at that exact point, the same way rubbing your hands together creates warmth from friction. Over weeks and months, that heat builds up, cycling on and off every time a light switches on, every time an appliance kicks in. Most homeowners never notice this happening because it's completely sealed inside a wall. There's no sound, no smell, nothing visible. The insulation around the wire slowly breaks down from the repeated heating, becoming brittle and cracked, like an old rubber band left in the sun for years. And once that insulation fails, the exposed wire is sitting inches away from wooden studs, insulation batting, and drywall paper, all of which burn easily. This is where professional electricians do something most people never think about. They don't just twist wires together. They use a specific mechanical connector, sized for exactly the wires being joined, and then they test the connection by tugging on it firmly. If it moves even slightly, it gets redone. That 5-second check is the difference between a connection that lasts 30 years and one that slowly cooks itself inside a wall for 3. But loose connections are just the beginning. The next mistake is one that inspectors say they catch constantly, and it's almost invisible until you know what to look for. It's called overloading a circuit, and it happens more often than most people realize. Picture a finished basement with a home theater, a mini fridge, a space heater for the winter, and a few lamps, all plugged into the same string of outlets. On paper, it looks like a normal setup, but each of those outlets might be wired back to a single circuit designed to handle a specific amount of power, similar to how a highway lane is only built to handle so many cars before traffic backs up. When too many devices pull electricity through that same lane at once, the wire itself starts heating up along its entire length, not just at one connection point. This is where the numbers actually matter, and it's simpler than it sounds. A standard household circuit is typically rated for 15 or 20 amps. A space heater alone can pull close to 15 amps by itself. Add a few more devices, and that circuit is working far harder than it was ever designed to. The wire inside the wall doesn't complain, doesn't spark, doesn't do anything dramatic. It just quietly runs hotter than it should, day after day, hidden completely from view. Homeowners usually get one warning sign, and it's incredibly easy to miss. A breaker that trips occasionally isn't a nuisance to be ignored. It's the electrical system's built-in alarm bell, doing exactly what it's supposed to do, protecting the wiring by cutting power before things get dangerous. The real danger begins when someone gets tired of resetting that breaker and decides to install a larger one instead, thinking a stronger breaker means a stronger, more reliable circuit. This single decision is one of the most costly and misunderstood mistakes in residential wiring, and fire investigators see the aftermath of it more than almost anything else. Swapping in an oversized breaker doesn't make the wire stronger. It just removes the safety net. The wire underneath is still the same size, still rated for the same limited amount of current, but now nothing will stop it from overheating. The breaker was never the weak link, it was the protection. Professional electricians approach this completely differently. When a circuit keeps tripping, they don't see it as an annoyance to override. They see it as a diagnostic clue, a signal that something upstream needs attention, whether that means redistributing the load across multiple circuits, upgrading the wire size itself, or adding an entirely new dedicated circuit for a power-hungry appliance. It takes longer, it costs more up front, but it solves the actual problem instead of hiding it. Now here's where the story usually shifts into something even more serious, something most people never think to check until it's far too late. Older homes across the United States, especially those built before the 1970s, often still contain a type of wiring that looks perfectly normal from the outside, but hides a design flaw that modern wiring doesn't have. It's called aluminum wiring, and for a period of time it was used as a cheaper alternative to copper. The problem isn't the aluminum itself. The problem is how it behaves at connection points. Aluminum expands and contracts with heat far more than copper does. Every single time a light turns on or an appliance runs, that wire heats up slightly and then cools back down, expanding and contracting in a cycle that repeats thousands of times a year. Over time, this constant movement causes the connection at outlets and switches to loosen, even if it was installed correctly to begin with. A loose connection, as we already know, means heat. And heat at a connection point inside a wall, hidden behind drywall, is exactly the kind of danger that builds silently for years before anyone notices anything wrong. Home inspectors trained to spot this look for specific warning signs the moment they walk into an older property. Discolored outlet covers, a faint warm smell near switches, flickering lights that seem to have no obvious cause. Any one of these on its own might seem minor. Together, they tell a very different story, one that often leads back to aging aluminum connections that were never properly addressed. The professional solution isn't always a full rewiring of the house, which surprises a lot of homeowners who assume the only fix is tearing out every wall. Licensed electricians can install specific connectors designed to safely join aluminum and copper wiring together, correcting the expansion problem at each connection point without replacing the entire electrical system. It's a targeted repair, done by someone trained to recognize exactly where the danger is hiding. But even newer homes aren't immune to serious wiring mistakes, and this next one might be the most avoidable of them all, which somehow makes it even more frustrating for the professionals who deal with the aftermath. Bathrooms, kitchens, garages, and outdoor spaces all share one thing in common: water. And water combined with electricity is one of the oldest, most well-understood dangers in the entire industry. This is exactly why a specific type of outlet exists, one designed to detect the smallest imbalance in electrical current and shut power off in a fraction of a second, faster than a human nervous system can even register a shock is happening. These outlets are easy to identify by the small test and reset buttons built into their face. Yet inspectors across the country continue to find bathrooms and kitchens wired with standard outlets instead, often because a previous owner replaced a broken outlet themselves and simply grabbed whatever was available at the hardware store, not realizing the location mattered as much as the outlet itself. It looks identical from the outside. It plugs in exactly the same way. But without that critical shutoff protection, a hairdryer dropped near a sink or a phone charger touched with wet hands becomes a genuine hazard instead of a moment that would otherwise trigger an instant, harmless shutoff. This is one of those mistakes that costs almost nothing to fix and yet gets overlooked constantly, precisely because it doesn't look dangerous. There's no exposed wire, no burning smell, nothing that visibly signals a problem. It simply sits there, waiting for the one moment water and electricity meet in exactly the wrong way. At this point, you might be thinking the biggest risks all come from tired old houses with outdated systems. But some of the most expensive mistakes investigators encounter happen in homes that are only a few years old, built during renovations, where homeowners handled the electrical work themselves to save money on a larger project. One of the most common scenarios involves finishing an attic or basement to add usable living space. It's an exciting project. New flooring, fresh paint, recessed lighting, maybe a small kitchenette. But wiring an entire new living area involves running cable through tight spaces, drilling through framing at very specific points, and connecting everything back to a panel that may or may not have room for additional circuits. This is where a single overlooked detail can undo months of otherwise excellent work. Wires running through wooden framing need to be protected at specific points, particularly where they pass through studs close to the edge, because a nail or screw driven later, maybe to hang a picture frame or mount a shelf, can pierce directly into that wire without any warning. Professionals install a small metal plate at these exact locations, a simple, inexpensive piece of protection that acts like a shield between the wire and anything driven into that stud in the future. Skip that detail, and you've created a hidden trap inside your own wall, one that might not cause a problem for years, until someone hangs a television and suddenly there's a spark, a tripped breaker, or worse, buried behind drywall where nobody can see it happening. This is the part where the story usually takes its most dramatic turn, because the danger isn't always immediate. Sometimes a mistake like this sits quietly for years, through several seasons of holiday decorations, birthday parties, and ordinary life, waiting for one random moment when a nail happens to land in exactly the wrong spot. There's one more mistake worth understanding, and it might be the most misunderstood of them all, because it involves a piece of equipment most homeowners have heard of but few fully understand: the electrical panel itself. The panel is the heart of a home's entire electrical system, the point where power from the outside world gets divided into individual circuits running to every room. When homeowners add new circuits themselves, whether for a hot tub, a workshop, or an electric vehicle charger, they sometimes discover the panel doesn't have room for another breaker. Instead of upgrading to a larger panel, which can be expensive, some choose to install what's known as a tandem breaker, essentially squeezing two circuits into a space designed for one. In some panels, this is a perfectly acceptable, code-approved solution. In others, it isn't, because that specific panel wasn't manufactured to safely handle the additional heat generated by doubling up circuits in that space. The difference between these two scenarios isn't visible just by looking at the panel from the outside. It requires knowing the exact manufacturer, model, and rating of that specific panel, information most homeowners never think to research before making a change like this. When done incorrectly, the result is a panel running hotter than it was ever designed to, in the one location in the entire house where every single circuit converges. It's the electrical equivalent of narrowing every lane of a highway down to one point and expecting traffic to flow normally. Professional electricians treat the panel with a level of respect that surprises people who've never seen inside one. Before adding anything, they calculate the total load already running through the system, compare it against what the panel and the main service can actually support, and only then decide whether a new circuit can be safely added, or whether the entire panel needs to be upgraded first. It's methodical, it's unglamorous, and it's exactly the kind of careful groundwork that prevents the disasters we started this story with. Looking back at everything that leads to a house fire caused by faulty wiring, the pattern becomes strikingly clear. It's almost never one dramatic failure. It's a series of small, invisible decisions. A loose connection here, an oversized breaker there, a missing protective plate, a skipped inspection, each one seeming harmless on its own, quietly stacking up behind walls where nobody is watching. The good news is that every single mistake we've walked through today has a straightforward, well-established solution. Properly sized connectors, correctly rated circuits, ground fault protection in wet locations, protective plates where wires pass through framing, a panel that's evaluated by someone who understands exactly what it can and cannot safely handle. None of these solutions are exotic or expensive in the grand scheme of home ownership. What they require is knowledge, patience, and in many cases, a licensed electrician who spent years learning to see the problems that remain completely invisible to everyone else. That family in Ohio never saw the wire that started their fire. They walked past that wall every single day for a year and a half, hosting dinners, watching movies, raising their kids, with absolutely no idea what was quietly happening just inches away. That's the real lesson hiding inside every one of these stories. The danger was never about being careless or reckless. It was about not knowing what to look for. And by now, you know exactly what that looks like. If today's investigation opened your eyes to something happening behind your own walls, imagine what we uncover next time. Because every week we take you inside another hidden construction failure most homeowners never see coming. And the next one might just be the story that changes how you look at your own house.